All right, so now that we have some newfound knowledge of parallel lines and how to prove them using these theorems, we're going to go ahead and try it. So the first thing you need to do is draw this picture into your notes, because there's no point in doing a proof without the picture. And we have to start with the givens and then make a set of logical statements and finally make a conclusion. So here's the picture. Go ahead and pause this if you need the time to draw it. I'm going to go ahead and shrink it now because it's going to be in my way. But we know what we were given. Now there's already some marks made on our picture here. And these little arrows, which I believe I've discussed before, but just in case I haven't, these two arrows here don't say that we're just drawing extra arrows. They actually imply, like being open and in the middle of the line, that this line is parallel to that one, which is given. The other thing that we know is that angle 1 and 3 are congruent. They told us that too, so I'm going to go ahead and mark that on my picture with these arc marks, marking them as congruent. So we're going to start with our first given. So given, so we've got our statements and our reasons. So we have P is parallel to R. Now what we like to do with proofs is take a piece of given information and use it right away. I'm going to pause for a second. Okay. And what we're going to try to do is get something we can use right away with that. And so we've got P and R, and we know something about what's going on here. And so we can, now they've only marked 3 angles in this picture, so that's probably all we need. Is there anything we can conclude? Now, the ones I've already marked are givens. What can we conclude about, I don't know, angles that touch P and R? So 3 touches R, and angle 2 touches P. Is there a special name for those 2 angles? That's what we should think about. And there is. Those 2 angles are on the outside, and they bounce around a transversal, which in this case will be M. And so those are alternate exterior angles. And since we know our lines are parallel, we can conclude that the alternate exterior angles are congruent. So angle 2 is congruent to angle 3, and that's the alternate exterior angles theorem. And I don't usually write down the word theorem, but I'll go ahead and do that this time. And that's from using this given right away. Now there's other stuff we can conclude about same side interior angles and all that stuff, but they've only marked those angles and we've used them. And angle 1 does not touch P or R, so it doesn't count. But let's go with our next given, which was that angle 1 and 3 were congruent. And that's also just given. So we're just using that piece of information. And so what we have here, and if you notice in my picture, these 3 angles are all marked as congruent. So because angle 1 and 2 must be congruent. Now what reason, I'm going to go ahead and write that down, but what reason am I using to say angle 1 is congruent to angle 2? What happened here? Well, angle 1 and 2 are both congruent to angle 3 in these previous statements. So let's go ahead and kind of underline that. What's that called? Well, we basically squished 3 out of the way. That's the transitive property of congruence. Transitive, I spelled that wrong. Transitive property of congruence. And we switched it out of the way. Now, what is the relationships between angle 2 and 1 and 2? Do they have a name? Well, now looking at L and M instead of P and R, those are both on the above line P or on the right of line P, and they are both in the same position, both above L and above M. So those are what kind of angles? Right, they're corresponding angles. So we're going to use corresponding angles because we just named some. And that's a postulate. But since we're going to go from corresponding angles to prove parallel, we're going to use the converse of the corresponding angles postulate to say that L is parallel to M. And we're done. That's it. So we've got these basic statements, and how we used everything was just by getting drew it. And that is our final proof.